Good morning, good morning. So we're gonna start today's session track. So in this HTML5 track, we're gonna have starting from blockchain and all the HTML5 related technologies and also API endpoint technology. By the way, my name is Ken, sorry. Hi, sorry. My name is Ken, Vice General Manager of Software Service Enablement Department. So we are a platform provider, developing group department in Rakuten group, and we are providing all those cool technology. So speaking about blockchain, of course, as you may know, we are very much focusing on centralized data initiatives. However, we believe this decentralized technology is also important. So out of 20,000 employees, only 10 people are working in a decentralized technology, which is, I think, very cool. And they are in Belfast. And today we invited my friend and colleague, Kevin Sullivan, and he's a senior developer of blockchain lab in Belfast. So we established this lab last year, August. So it's a little bit over 1 year, and we are making a lot of progress. So today he's going to introduce identity on the blockchain. So with this, please let me introduce Kevin. So please come to.
Good morning. So today I'm going to talk about identity on the blockchain, and in particular how the characteristics of blockchain can help us solve some of the issues involved with identity. So first of all, I'd like to describe what I mean by identity. I want to kind of distinguish a little bit between two different terms. So an identity, what I'm talking about is a unique identifier, unique information that can identify, say, an individual or a thing. And I mean thing because, of course, an identity doesn't have to be a person. It could be an organization or a company or even a device. And it's what I mean is there's a one-to-one mapping. So there's some kind of unique information to identify the entity. So in the case of a person, that would be maybe biometric data or a passport even. And on a device, it could be a unique device ID. And then a digital identity is more of just a collection of digital information which is available that describes that entity. And in this case, you can have many different digital identities. So, as a person, you could have a professional identity that you keep separate, maybe from your personal life, or from an identity that you use to follow a sports team or something like that. And the blockchain. So, I'm not going to go into much detail about blockchain, how it works. I'm hoping everyone has at least heard of blockchain and has some idea of what it does and how it works. If not, please feel free to talk to me later on. But for the purpose of this talk, I'd just like to point out two characteristics of the blockchain that will help us when dealing with digital identity. And the first is that it's decentralized, right? So a blockchain by its nature is decentralized. It typically runs over a peer-to-peer network. And decentralization gives us some benefits. So you've got high availability, you have accessibility from anywhere in the world, and more importantly, there's no single point of failure. There's no one organization or company that controls all the data. And this is very important. I mean, we've seen recently with the Equifax breach in the US that one organization got hacked and lost customer data on millions and millions of people. And that's not the first, it won't be the last, right? So this has happened time and time again. And the other characteristic of blockchain is that it's the cryptographic mathematics. So you could describe a blockchain as being a cryptographically secure record of things that have happened. And again, I'm not going to go into the details of this, but for the purpose of this talk, let's just all agree that a blockchain is cryptographically secure, which means the date on a blockchain is immutable and irreversible, so you can't delete anything from a blockchain or you can't change it. So, your identity. Let's talk about an individual. When you have you are yourself, and then you've got lots of attributes that describe your identity. So you have your Twitter ID, your Facebook, and these attributes can be digital or non-digital. So you have your date of birth, your nationality, your passport number, etc. Okay, so all of these things together make up an identity. But how do you know that these attributes actually belong to you, or belong to the identity in question? So in the real world, typically there's a trusted government organization that issues a passport, and you have some trust in the government or a certificate authority that you know that that it belongs to you. But in the online world, it's not so easy, right? So to get a Facebook account or Twitter, you typically only need an email address, right? Once you have an email address, you can get lots of other types of accounts. But email addresses are easy to make, easy to fake, right? You can have many email addresses, and no one checks that they actually belong to you. So I guess what we might need, or what would be nice, is to have something in the online world that could act as a trusted route, that you could trust, that could link an identity to something else. So this is where blockchain comes in. We can use the cryptographic characteristics of blockchain to build up a trust model. And a trust model could look something like this. At the bottom, you've got trust anchors, and these are, trusted organizations or entities that you have trust in, that can weigh down the bottom of a chain. And trust anchors issue proofs, and these proofs can verify claims. An identity then is a collection of claims or attributes that describe themselves. So the proofs that I spoke about at the bottom of the trust anchor, how do they work? Well, on the blockchain, proofs work through digital signing. And digital signing comes built into a blockchain, right? The blockchain works on the concept of digital signatures. The digital signatures are nothing new, they've been around for a long time, but because they come built into a blockchain, it makes it a lot easier. And a digital signature is really a way of using cryptography to prove that someone is who they say they are. And it really works using public and private key pairs. I hope you're at least familiar with the concept, but just as a brief summary, the person who's creating the proof, or the trust anchor, usually will create a hash of the claim and encrypt it with a private key. And this is the signature, and that goes on the blockchain. And then if anyone wants to come and verify that claim, you take the proof on the blockchain and you decrypt it using the trust anchor's public key. So if the decrypted hash that you've just decrypted is the same as the hash of the claim you're trying to verify, then you can be confident that it's the same thing as that trust anchor signed in the first place. So let's take an example of that. So if I claim that my mobile phone number is 555 whatever. So for a trust anchor to verify that, it's kind of easy. They can send a text to my mobile phone number with a code, and then I return the code to them, and then they're happy that this is my phone number. So then once they're happy about that, they can issue a proof for that and put it on the blockchain. And then if a third party wants to verify that that's my phone number, they don't have to do the same process. All they do is check the proof on the blockchain, verify it, and then they're happy that that is my phone. Similar with a passport, right? So this is a bit more complicated process for the trust anchor. So, if I claim that this is my passport, this is my nationality, then a trust anchor, who's someone like a bank or someone who has a KYC process, they do this all the time, and they will have a process that you can go through. So, typically either you have to go in person, or you can do it over the phone, or send a picture of your passport. And they can check the passport, they can check the security features of the passport, they look at the photograph, or they test it against the government database that it's a valid passport. And once they're happy with that, then they issue a claim for it. Again, they issue a proof, and they put it on the blockchain. And then a third party who need to know my passport number, like an airline company, They don't need to go through the same process because the bank has already done that, and they trust the bank. So they just go to the bank, the blockchain, they look up the bank's proof, they verify with the public signature of the bank, and then they know that that password is valid. So we've talked about putting things on a public blockchain, and we have to consider privacy and data protection. And it's important to realize that we're not putting the data directly on the blockchain. Instead, we're putting a hash of the data on the blockchain. And a cryptographic hash is a one-way function that transforms data into usually a string of numbers. So for example, here's my email address, and hashed, it comes out as this number. And you can't go backwards, you can't get my email address. If you see this number, you can't get my email address from it. But what you can do is hash my email address and verify that the number is the same thing. Okay? So the actual identifying information is not on the blockchain. And in the world of smart contracts, which on the Ethereum network or the Neo network are becoming more popular, that gives you even more power of the data that you can and can't show. So a smart contract could make it so that you only reveal a minimal amount of data. For example, if I need to prove that I'm over 18, a smart contract can allow me to just say, yes, I am over 18, but it doesn't have to show that I'm 18 or 28 or 88, right? Because the person who needs to know I'm over 18, they don't need to know my date of birth, or they shouldn't know that. So a smart contract can help in just providing the minimum amount of information that's necessary. Of course, the data doesn't have to be private. If you want your data to be public, you can do that as well. And more, it's becoming more apparent that your data is valuable. Right? There are lots of companies out there. I'm sure everyone in this room, their data is being sold or has been sold by somebody somewhere to an advertiser or something like that. And there are some providers trying to address that problem or issue. For example, there's a blockchain-based identity provider called Sovereign, and they're introducing the concept of premium claims, where the user can publish their data but charge money from it. They sort of put a price on it and go to, if an advertiser wants to pay for that money, then they get it. And because it's blockchain based, and most blockchains have some kind of token involved, like Bitcoin or Ethereum, because it's on the blockchain, paying the user back is automatic. It happens right away. You don't have to wait for a third party or settle a bill at the end of the month. Another feature of the blockchain worth mentioning is its network effect. And the network effect is a phenomenon where the more people are involved in a network, the more value the network has. Right? So for identity, the more members you have it, then the more trust anchors, the more proofs, the more value the whole thing has. And this is just an example of my Keybase profile. And Keybase is a digital identity provider, and they link up with people like Twitter, Facebook, GitHub, Reddit, and you can prove your identity on this, and they will hash the proof and publish it on the Bitcoin blockchain. And because they get all these providers together into one, then it gives their network much more value than if they were on their own. Apart from Keybase, there are quite a number of companies already doing digital identity. So Sovereign, which I mentioned previously, Keybase, Showcard is one that's based on mobile identity. Civic Uport is on the Ethereum blockchain. So they're all very interesting projects and definitely worth looking into. It's also worth mentioning Estonia as a country. The Estonian government have issued a blockchain-based national identity, and it's been hailed as a great success because it significantly reduces bureaucracy in the country to do business-related or So, challenges. I mean, this is not a solved problem yet, right? There's still some issues that we need to consider. The first is, so where does your identity, your root identity, come from? And in the real world, this is usually a government or some kind of government organization that will provide you with a passport. However, there are over 1 billion people in the world today with no officially registered identity, and the UN have stated that identity is a basic human right, and they've introduced a project called ID 2020, wherein they hope that by the year 2030, everyone on the planet will have access to some kind of digital identity. And actually Microsoft and Accenture have already brought out a blockchain-based prototype on this project. And then the trust anchors we talked about, who verifies the identity of them? Well, again, they're usually some kind of trusted organization due to their reputation, either a government or a certificate authority or something. But there's also a movement going on to get away from that model. And there's a W3C draft to do with decentralized identifiers. And decentralized identifiers do away with the trusted real-world organization, and they state that just having control of a private key on a blockchain is enough for an identity to be its own trust anchor. Now, this might not be sufficient for some KYC processes, but for a lot of other applications, that's probably enough. And data protection regulations. So next year in 2018, Europe are redoing their data protection regulations. Are becoming much more strict, right? They want much more control over access and territorial access to data. So any data identity provider will really have to make sure that they're going to comply to these rules. So it's work to track these regulations and comply with them. And one of the big ones is the right to be forgotten. That's involved next year in the European regulations, and this is really an issue for blockchain because, as I said, the blockchain is immutable, right? You can't delete anything on blockchain by its nature. So it's not clear yet how we're going to get around this issue, right? So, I mean, there have been suggestions maybe you can lock up data forever on the blockchain, but it still remains to be seen if the EU regulators will consider this as compliance with the regulations. So that's really all I have this morning. I've tried to show that the blockchain and the particular characteristics of blockchain can help us with digital identity, and that blockchain is really an appropriate platform to use in this area. Are there any questions?
What's next?
What's next? Well, as I said, these projects are ongoing. Some of them are live already. You can create your identities on these platforms, and they're there. Next is to get widespread use. Again, the network effect is very important. The more people use it, the more value it has.
Regulated.
And regulations, yeah. I mean, lots of experts are now saying blockchain are usually identified with fintech, right? People are now starting to say, well, it's actually more regulation tech, right? So blockchain is very interesting in that it can satisfy a lot of the regulations, right? You don't need paper anymore and lots of bureaucracy and copies in triplicate. If something is on the blockchain, then it can usually satisfy most of the regulations. But there's a lot of talk to be had with regulators and lawyers to see if that's actually going to be true.
And any tokenizing blockchain activities, like connecting it with a bio integration kind of concept? For instance, a token that goes as an earring.
A token that goes in the earring. I'm not aware of anything like that. What I'm aware of is stuff like putting biometric data on the blockchain, so palm prints and fingerprints. That's kind of easy because you can hash up the data and put them on a blockchain. The Internet of Things is using the blockchain as well, so I guess earrings and stuff like that. It's being done. It's not difficult, and I guess the most important challenge in that is what do you put in the earring and what do you put on the blockchain, right? So if you put just an identifier for the earring on the blockchain, then it doesn't really get you all that much. However, if the earring can point to a smart contract on the blockchain, then you probably have a lot more potential in what to do with that data or with that identity. And so, yeah, it's being done.
Do you see this as kind of existing as its own blockchain instance? Or would it be part of a general purpose blockchain like Ethereum?
Yeah, it could be either. I think it's more valuable as a general purpose blockchain, like it's on the main Ethereum blockchain. I think it has more value there because it's more open, more public. Anyone can.
So blockchains, they usually have an incentive.
Yeah, right. I mean, part of
if it's just identity, maybe you don't. Why would you put your CPU and your network up into that?
Right. So, I mean, one of the arguments for blockchain is that it is public. There's a lot of people say a private blockchain is not a blockchain, right? So, when you have a public blockchain, you get much more of the advantages of blockchain. However, there are companies, and regulation comes into this, that you can't put everything public, right? So what they call a consortium blockchain, which is a kind of semi-private permissioned blockchain. So you control access to it. So it's still a network, and it can be run on peer-to-peer nodes all over the world, but you need some kind of control over access to it. Again, there's pros and cons for either side.
I was curious about the idea of selling the personal data on the blockchain.
Yeah.
How can it be possible to do that only on a smart contract? Because you can't decrypt a data on a smart contract while through a single person.
Yeah, that's true. There are quite a few challenges in that, because the smart contract needs access to the data, and if it's encrypted, then how do you decrypt it? Well, you can pass, password hashes or stuff to the smart contract, so the data is encrypted, but it can dynamically decrypt it. Right. So there are ways around it, but you're right. That is a challenge. Yeah. It is possible to do though. I think I'm out of time. If anyone has questions, feel free to talk to me later. Thank you very much.